Hello everyone. In this video, we're going to determine the inverse of logarithmic function, and this is the first part. Before we go into this example that we have right here, let's have a review on how to change logarithmic form to its equivalent exponential form. We remember that logarithmic form can be converted to its equivalent exponential form following this general rule right here. That this base of this logarithmic equation that we have here is the same base in the exponential form. So I'm going to move that up here. Now this m that we have here is the exponent of the exponential form. And this argument a will become the value of this whole exponential expression on the left. And this is how we convert a logarithmic form to its equivalent exponential form. Okay, going back to the example that we have here, again, we're supposed to determine the inverse of this function f of x is equal to log of x to the base 5 minus 3, or this can be read as f of x equals log base 5 of x minus 3. There are steps that we need to follow in order that we can determine the inverse of this logarithmic equation that we have here. The first step is to replace f of x with y. So in this problem right here, I can go ahead and change this f of x to y, and then just copy the rest of these log of x to the base 5 minus 3. Now we're ready to move on to the second step. The second step is to replace every x with y and every y with x. Isolate the logarithmic expression on one side of the equation, convert the logarithmic expression to its equivalent exponential form, solve for y. So in this problem right here, we are going to replace this y with x and this x with y. So I'm just going to write it down here. Okay, now we are going to isolate the logarithmic expression on one side of the equation. So we need to have this by itself on this side, but we have the minus 3. So what are we going to do is we're going to add 3 to both sides so we can get rid of this 3. Okay, so right now we are left with x plus 3 equals log of y to the base 5. So we already isolated the logarithmic expression on one side of the equation. Now the part of the second step after we isolated the logarithmic expression here is to convert this logarithmic expression to its equivalent exponential form. So we remember that we can change this logarithmic expression to its equivalent exponential form using this general rule right here. So if we are given log of y to the base b equals x, all we need to do is we go ahead and say b to the exponent x is equal to y. So then we can go ahead and say that this base that we have here is 5. So I go ahead and write 5 to the exponent x plus 3 equals y. So I'm going to write that down here. Okay, as you can see here, we already have isolated y by itself here on this side. We're ready to move on to the third step. The third step is to replace the y of the equation solved in step 2 with f negative 1 of x. So pretty much this final equation that we have here for the inverse would be f negative 1 of x, that's the y, is equal to, that's gonna be 5 to the power x plus 3. And this is the inverse of this given equation that we have up here. On the side, you will see the graph of the function and its inverse. In red, you will see the function y is equal to log of x to the base 5 minus 3. And the one in green, it's its inverse, which is y is equals to 5 raised to the power x plus 3. You can see that these two graphs are symmetric with respect to its line of symmetry, y is equal to x. This tells us that these two graphs are actually inverse of each other. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, there are steps that we need to follow in order that we can determine the inverse of this function. The first step is to replace f of x with y. So this f of x here becomes the y, and I'll just copy the rest of them here. Okay, so I've changed the f of x to y, and it turns out to be y is equal to log of x minus 1 to the base 3 plus 2. Now we're ready to move on to the second step. The second step is to replace every x with y and every y with x. Isolate the logarithmic expression on one side of the equation, convert the logarithmic expression to its equivalent exponential form, solve for y. So in this case right here, I am going to change this y to x and this x to y. So this becomes okay, part of this step is to isolate this logarithmic expression on one side of the equation, but we have a plus 2. All we need to do is to subtract 2 from both sides. So minus 2 and minus 2. So then we can cross the 2 out. So then we are left with... Okay, so we already have isolated the logarithmic expression on one side of the equation so that we can go ahead and convert this to its equivalent logarithmic form. We remember that if we're given a logarithmic form, we can change it to its equivalent exponential form following this general pattern right here. So whatever the base of the logarithmic expression is, b raised to the exponent x is equal to y. So in this case right here, I'm going to have 3 as the base. So that would be 3 right here. And then that is raised to the power x minus 2. So I'm going to write the x minus 2 as the exponent now. And that is equal to the argument, which is y minus 1. So I'm going to write y minus 1. So then again, we are supposed to solve for y here since we still have the minus 1. So I'm going to go ahead and say plus 1 and plus 1 to both sides so that I can cross the 1 out. So then we are left with 3 raised to the power x minus 2 plus 1 is equal to y. So we already have isolated y by itself, and that's part of the second step. Now we're ready to move on to the third step. The third step states that replace the y of the equation solved in step 2 with f negative 1 of x so that we can go ahead and write this as that's gonna be f negative 1 of x that represents the y is equal to 3 raised to the power x minus 2 plus 1. So the 1 here should not be part of the exponent there. So that is a plus 1 here. So this is our inverse, or this is the inverse of this function that we have up here. On the side, you will see the Desmos graph of these two functions. You will see the graph of the function in red, which is log of x minus 1 to the base 3 plus 2, and the inverse function in blue, which is 3 raised to the power x minus 2 plus 1. You will see that both of these graphs are actually symmetric with respect to the line of symmetry y is equal to x, which means that if we fold this graph along the line of symmetry y is equals to x, they're gonna match up. This tells us that these two functions that we have here are inverse of each other. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!